So we are going to start now with economic minerals because in our videos so far in this unit we have petroleum all done. So what is an economic mineral? An economic mineral or minerals are minerals that can be taken out of the ground, extracted, processed, and then marketed at a profit. So essentially an economic mineral is a mineral that a profit can be made from. Now, whether a mineral is economic or not, or whether a mine is going to open or not, really depends on several factors. One being, is it a mineral that we are interested in? Is the deposit a big one or a small one? Is the mineral concentration high or low? Is it deep below the surface or shallow to the surface? And is the market value of the mineral high or low? Obviously, it needs to be a mineral that we're interested in. The bigger the deposit, the better. The more concentrated, the better. The closer to the surface, and the higher the market value. They are basically the factors that we want to be in favor of a mine opening. What is an ore? An ore or an ore body is just basically a natural buildup or a natural concentration whereby you have at least one mineral that's of economic value. There could be two, there could be three, there could be five, there could be six, but there needs to be at least one mineral in that ore that you can basically extract and process and make a profit from. So in class I showed you guys an example of a rock from Voisey's Bay in Labrador, and it is classified as ore. There's about 5 different minerals in the rock. However, there is mostly one that is of economic value that our province is interested in, and it's a mineral called pentlandite, which is mined for nickel. We obviously need mines, and I always say to students, if it's not something that you can grow in the ground, then it needs to be mined. We need mines for a lot of different things. If you just look around your house, look at cars, look at the things you use, the things we wear, quickly, like jewelry, you'll realize that minerals are of an essence. They're absolutely significant in our everyday life, and we totally need them. So there's 10 different deposits that we need to learn about, and I'm going to go through them I guess as quickly as I can. The first deposit type is going to be magmatic deposits, and there's 2 kinds of magmatic deposits. There's magmatic layered and magmatic disseminated. Basically, magmatic layered is the one that we like the most because the magma is new and it's incredibly hot and is predominantly liquid. So what happens is minerals of high density crystallize out first at very high temperatures, and because they're so heavy and because the magma is predominantly liquid, those minerals sink to the bottom of a magma chamber and creates a layer at the bottom. In this particular diagram, one of the minerals that we're basically showcasing is a mineral called chromite, and chromite is mined for chromium, which is an element on the periodic table. And so because chromite crystallizes at high temperatures when the magma is mostly a liquid, gravitational settling takes over and the chromite minerals sink to the bottom of the magma chamber, forming a high concentration layer. And just keep in mind, because all the chromite is in a layer, then the concentration of this deposit is high. And so that is something that we look favorably upon. It is also possible, though, that some of the deposits that relate to magma chambers could be disseminated. So let's say, for example, that we had a magma chamber and the magma chamber is almost solidified. So let's say 90% solid and only 10% liquid, and all of a sudden a mineral crystallizes that is of economic value. Problem is, because the magma chamber is mostly solidified, this time it can't sink to the bottom of the magma chamber, so it's basically going to stay in position wherever it is. And as a result, that economic mineral will be seen as being speckled or spread throughout the magma chamber, and that's where the word disseminated comes from. Obviously, you would have to go through the entire magma chamber of rock in the future to basically pick out the disseminated mineralization that you're actually looking for. And as a result, we look at a disseminated magmatic deposit as being low concentration.